The flags are flying. The balloons are ready for release. It's a great day, one we have been planning and waiting for. I am sure you will concur. This is an agreeable welcome. I am Professor Muhammad Ahmad Qureshi in Civil Engineering Department at RNG Patel Institute of Technology, Bardoli. Till now, we had studied mechanics of solid subject in which we have gone through engineering mechanics, basic fundamental concepts, principle of mechanics, that is parallelogram law of forces, principle of transmissibility, principle of superposition of forces, Newton's first law, second law, and third law of motion, as well as Newton's law of gravitation. We had also studied force, characteristics of force, and system of forces. Also, in the previous lecture, we had gone through parallelogram law of forces and its examples. Now, we will study about coplanar concurrent forces. In that, we will go through resolution of a force. So, what do you mean by resolution of a force? It is nothing but a process of splitting up the given force in two or more components in a particular direction without changing the effect on the body. So, there are two types of components. First is orthogonal components and second is non-orthogonal components. First, we will go through orthogonal components. What are orthogonal components? The components which are perpendicular to each other or the components which make 90-degree with each other are known as orthogonal components. Generally, a given force is split up in two mutually perpendicular components. First is horizontal component, that is nothing but your x component. First is horizontal component. Horizontal component is nothing but it will take place in x direction. And second is vertical component. Vertical component generally takes place in y direction. So the horizontal component is known as x component and the vertical component is known as y component. So let us take an example for this. Suppose this is your x-axis and this is your y-axis. So first we will take the P force as tensile force acting at an angle theta with x direction. Remember one thing, whenever a force ejects from one point, it will makes an angle theta with x axis only. So for this component, for this P force, we have two components. First, we had seen here which component? One is your horizontal component. So one horizontal component is P, and we have seen that horizontal component means x component. So whenever we are considering horizontal component, use cos and the angle is theta, and for vertical component we have P sine theta. So by this you can split the given force in two components, horizontal as well as vertical components. Similarly, if your P force is in second quadrant, then you may split your force like this. This is your P force, and P force makes an angle theta with x axis. So here there will be two component. First is horizontal. So in horizontal, P and horizontal component makes with x-axis. So this will be your P cos theta, and here P sine theta. Similarly, you may plot your P force here. So you will get, this is suppose your P force. So this will be your P sine theta, and this will be your P cos theta. So in orthogonal components, you can split the given force in two mutually perpendicular components. One is P cos theta and the other is P sine theta. Now we will go for non-orthogonal components. So what are non-orthogonal components? Second is your non-orthogonal components. Means they are not orthogonal. So these components are not perpendicular to each other. This component makes either obtuse angle, that is theta greater than 90 degree, or they may make acute angle, that is theta less than 90 degree. The components those are not perpendicular to each other are known as non-orthogonal components. So non-orthogonal components can be calculated using parallelogram law of forces, or by using triangle law of forces. How can we go through parallelogram law of forces? We had already seen in the previous lecture that your resultant force capital R in case of parallelogram law of forces is given by under root of P square plus Q square plus 2PQ cos theta. And we can find the direction by using the equation tan alpha equals to Q sine theta upon P plus Q cos theta. Here, what is theta? Theta is nothing but angle between P force and Q force. And by using triangle law of forces, we can find the resultant by using the formula capital R equals to under root of P square plus Q square minus 2PQ cos beta, and we can find the direction by using equation tan alpha equals to sorry alpha equals to sine inverse q by r sine beta. And what is beta? Beta is nothing but 180 minus theta, or we may say that alpha here, alpha is the angle between P and R. So generally the given force can be split up in two or more components in a particular direction only without changing the effect on the body, and this method is known as resolution of a force. There are two types of component. First is orthogonal components and the second is non-orthogonal components. What are orthogonal components? The components which are perpendicular to each other, or the components which make 90-degree with each other, are known as orthogonal components. And what are non-orthogonal components? The components those are not perpendicular to each other are known as non-orthogonal components. Non-orthogonal components make either obtuse or make acute angle, and non-orthogonal components can be calculated using parallelogram law of forces or by using triangle law of forces by using these both formulas. Now, we will solve the examples on orthogonal and non-orthogonal components. So, first example, what is given? Resolve 100 Newton force parallel and perpendicular to axis MM as shown in figure. So, here is our axis MM and 100 Newton force that we have to resolve. Here the value of alpha is unknown, and here the value of theta is also unknown. So first of all, we can easily calculate theta as the slope is given. So first of all, tan theta equals to 4 by 3, and 4 by 3 is nothing but 1.333. Therefore, theta will be 53.13 degree. So here we get the value of theta as 53.13 degree, and here angle is 45. So only the unknown value is alpha. So we may calculate alpha easily. Alpha equals to, here the total will be 180. So 180 degree minus 53.13 degree minus 45 degree, which will be equals to 81.87 degree. So Here we get the value of alpha as 81.87 degree, and angle alpha is in between axis mm and 100 Newton force. So here is your axis m and 100 Newton, and the angle between the both the forces is nothing but 81.87 degree. So this 100 Newton force can be resolved in two components. So here first component is 100 cos alpha and the second component is 100 sin alpha. So first of all we will resolve the component parallel to which axis? Mm, parallel to mm. So in this case it is parallel and force is 100. So 100 into parallel means cos component, cos, and what is the value of alpha? Alpha we have 81.87. So 100 cos alpha is nothing but 100 into cos 81.87 degree, and by solving this you will get 14.4 Newton. So this is the way how you can calculate the component parallel to mm. Now we will calculate the component perpendicular to mm. So our next step will be component perpendicular to mm. Perpendicular to axis mm. So in this case perpendicular means your this component sine component force is given as 100 into sine alpha. So 100 into sine, and the value of alpha that we have achieved is 81.87 degree. So your final answer will be 98.99 Newton. So we have resolved the 100 Newton force that is parallel and perpendicular to axis mm. You can easily calculate and you can easily resolve the forces with respect to some axis that we have. We will go for second example. Suppose along 90 degree x and y and non-orthogonal axis AA and BB. So here x, y are orthogonal axis, B are non-orthogonal axis. We have to resolve. So first of all, we will resolve the 100 Newton force along orthogonal axis, that is x and y. So you may see here this is 100 Newton. So I am plotting this 100 Newton over here, and 100 Newton makes an angle 30 degree with x axis. So here 100 Newton making an angle 30 degree with x axis. So this component can be split in two mutually perpendicular components. So here your one component will be in this direction and it is 100 horizontal axis, therefore the component will be cos, and here vertical That's why it is given as sine. So 100 Newton force along x-axis and y-y. The 100 Newton force has two components, 100 cos 30 and 100 sine 30. So first of all, we will resolve the component. So component along x-axis will be 100 cos 30 degree will be equals to 86.60 Newton, and the component along y will be equals to 100, this portion 100 sine 30 degree. By solving, you will get as 50 Newton. So we had resolved the 100 Newton force along orthogonal axis x and y. Now we will go through non-orthogonal axis A and B. So this is your AA axis and BB axis. This is the simplified figure of the given figure. So now 100 Newton force is given, and the angle between 100 Newton force and axis A is given as 50 degree, and the angle between axis B and 100 Newton is given as 20 degree. So now we have to again simplify the figure with reference to the angle. So we know that this whole angle is 180 degree, and out of 180 degree we have 20 degree this. So we may calculate this angle as 180 degree minus 20 degree. So you will get here as 160 degree. Then here also total is 180 degree, and out of 180 degree we had given this angle as 50 degree. So 180 minus 50 degree you will get as 130 degree. Now we have two axes A and B. So let us denote both the axes with some force. So here at axis A point we had given P force, and at axis B we had assumed Q force. So here is your axis A and it is denoted by P force, and here is your axis B which is denoted by Q force. And the angle between A and B is nothing but 50 plus 20 means 70 degree, and this 100 Newton force, resultant force, we are considering as equilibrium force in opposite direction but of same magnitude. We have just 100 Newton given here only. So now this is 70 degree, this angle is 160 that we had calculated here, and this is as 130 degree. So now we can apply the sine rule, and we will get the value of unknown force P and Q. So now using sine rule, So your one force is P upon. So here is your point of application, and from here your P force is going outward. So the angle opposite to P force means this angle is 160. So P upon sine 160 equals to, we are taking the another force Q upon sine 130 130 equals to, the other force is 100 upon sine, the angle opposite to 100 Newton force is 70 degree. So now we have A equals to B equals to C. So we may go for A equals to C and B equals to C. Likewise, we will go for P upon sine 160 equals to 100 upon sine 70 and Q upon sine 130 equals to 100 upon sine 70. So, by doing this, we can easily get the unknown values of both the forces. So now, therefore, P upon sine 160 degree equals to 100 upon sine 70 degree and Q upon sine 130 degree equals to 100 upon sine 70 degree. So here P equals to sine 160 into 100 upon sine 70 and Q equals to sine 130 into 100 upon sine 70. So therefore your value of capital P you will get as 36.4 Newton and value of Q will be 81.5 Newton after solving the above equation. So likewise, you may go for non-orthogonal axis if you had asked in this example. So this way, we had resolved the 100 Newton force along orthogonal axis XX and YY and non-orthogonal axis AA and BB. Simple equation. Just go for cos theta in case of horizontal component and go for sine theta in case of vertical component. And here basic rule, sine rule, you have to just put all the three forces in terms of equation and you have to solve the equation and then you may get the unknown value of forces. Now, we will go for third example. What is given? Resolve 75 Newton force along MM and NN axis. So here, the given data, you may see that 75 Newton force, you have to resolve it. So, let us go for this example. Here, 75 Newton in downward direction and axes are M, M and N, N. So I am just simplifying this figure and converting into this figure. So here R 75, here R is 75 kilonewton in downward direction. And for the axis NN, I am plotting this N axis and I am indicating this axis by Q force And for this axis mm, I am indicating this axis with P force. So the angle between 75 kilonewton and this axis means with P force is given as 60 degree. So I am just putting this as 60 degree, and the angle between the 75 kilonewton force with N axis means by indicating with Q force is nothing but 45 degree. Now what I am doing, I know that from this point till this point we have an angle of 180 degree. So total 180 degree minus the given angle, that is 60. You will get this remaining angle as 120 degree, and similarly here total is 180 degree. So 180 degree minus angle 45 is given. So minus 45 degree. So you will get 135 degree, the remaining angle from here till here. So now I have to apply the sine rule, and for sine rule this resultant force or this force must be converted into equilibrium force. So I am taking this force in opposite direction with same magnitude and indicating the P force, and the angle between the P force and equilibrium force R is nothing but 120 degree, and the angle between the P force and Q force is 60 plus 45 degree, that is 105 degree, and the angle between the equilibrium force R and Q force is nothing but 135 degree. These both the angles we have calculated earlier. Now I have to apply the sine rule for calculating the forces. So according to sine rule, we may have equation as P. I am considering this force first. So P upon point of application is here. So the opposite angle will be 135. So P upon sine 135 degree equals to Q. I am considering this as second force. So the opposite angle will be this 120, Q upon sine 120 degree equals to resultant R dash, that is known value 75. Opposite angle is 105 degree upon sine 105 degree. So I got the equation as A equals to B equals to C. C is known value. So we may write that a known value, that is P upon sine 135 degree equals to known value 75 upon sine 105 degree. And similarly we may write as Q upon sine 120 degree equals to known value 75 upon sine 105 degree. So after solving this equation as P equals to sine 135 into 75 divided by sine 105, you will get the value of P as 54.9 Newton, and the value of Q as sine 120 into 75 upon sine 105. So your Q will be equals to 67.24 kilo Newton. Here also kilo Newton. So we had calculated both the values of unknown forces P and Q. Likewise, you may solve all the examples related to orthogonal and non-orthogonal axes. It is simple. Just you have to use the sine function, and you may use the component along x and component along y for solving the orthogonal components. So, till now, we had studied the resolution of forces. What is resolution of force? Just we go through revision. What is resolution of force? The process of splitting up the given force in two or more components in a particular direction without changing the effect on the body is called resolution of a force. And in resolution of a force, there are two components, orthogonal components and non-orthogonal components. Orthogonal components are those components which are perpendicular to each other, or the components which makes 90-degree with each other. Generally, a given force is split in two mutually perpendicular components, that is horizontal component x component and vertical component, that is y component. And non-orthogonal components are those which are not perpendicular to each other. They make either obtuse or acute angle. And non-orthogonal components can be calculated using parallelogram law of forces or triangle law of forces. So, now in the next lecture, we will go for resolution of more than two concurrent forces. Till now, we have resolved only one force, that is resolve 100 Newton force, resolve 100 Newton force, and resolve 75 Newton force. Now we have to resolve more than two concurrent forces. So in the next lecture, we will go for the examples related to more than two concurrent forces. So thanking you. We will meet in another lecture.